Good morning, my dear lovely students. Now, in the last class, we have discussed in kinematics speed, velocity. What is the difference between speed and velocity? At the same time, in the speed, we have discussed average speed, instantaneous speed, and some problems on the speed. Now, in today's class, we are going to discuss about average velocity. So, what is the difference between average velocity and velocity? When we are going to calculate average velocity and when we are going to calculate velocity. Velocity is calculated at particular instant of time. So, it is also known as instantaneous velocity. When I come to the average velocity is calculated in a time interval of time. So, if you calculate the velocity in the interval of time, it is known as average velocity. In the last class, we have discussed what is a speed and average speed. In order to have a clear idea between average velocity and average speed, we are going to do some numericals. If you do the numericals, we can easily understand the difference between average velocity and average speed. See this problem. A car moves 20 kilometers in 3 hours in a straight road. After traveling 20 kilometers, he takes a reverse gear and moves 4 kilometers. So for that, it takes 1 hour. Now, we want to calculate the average speed and average velocity of the car. So, in the last class, we have discussed the formula for average speed. What is the formula for average speed? That is total distance by total time. Total time. Here, in first he has traveled 20 kilometers in straight, and he has traveled 4 kilometers in back. So totally 20 plus 4, that is 24. For time we want. For 20 kilometers, he takes 3 hours. For 4 kilometers, he takes 1 hour. So 3 plus 1, that is 4. So 4 ones, 4 6. That is 6 kilometer per hour. So this is the average speed of the car. Now we are going to say average velocity of the car. Average velocity of the car. So average velocity equal to, we know the formula, that is total displacement. Total displacement by total time. So total displacement. Now we want to, in order to calculate the total displacement, we should be very careful. For example, let us consider this is starting point of the car. He has traveled 20 kilometers. Let us consider 5 kilometers up to here. It is 10, 15 and 20 kilometers. So, he has traveled 20 kilometers. Then he has taken a reverse gear and has moved 4 kilometers. That means nearly here. So, this becomes final point and this becomes initial point. So, we know the displacement formula, final position minus initial position. Here the value will be 16. So, 16 minus 0, that will be 16. And the total time, that is 3 plus 1, 4 hours. So, 4 ones, 4 fours, that is 4 kilometer per hour. So, this is average velocity and this is average speed. If you observe here, the average speed value will be greater when compared to the average velocity. So this is about average speed and average velocity. There is one more property in the speed, that is uniform speed. Uniform speed. In order to discuss about the uniform speed, first of all, we want to know uniform motion. Coming to the uniform motion. So, A be the starting point and E be the final point. So, from A to E, let the distance is 16 meters. Now, a person starts from A and reaches to B, that is a distance of 4 meters from the origin in 2 seconds. And he reached to point C, that is a distance of 8 meters from the origin in another 2 seconds. Now, he reaches from A to D, a distance of 12 meters from the origin in another 2 seconds. And he reaches from A to E, that is 16 meters from the origin in another 2 seconds. Now, here the distance traveled by the person, he has traveled equal distance in equal interval of time. See, A to B, the distance is 4 meters. The time taken is 2 seconds. B to C, from here to here 8 meters. That means from here to here it will be 4 meters. So, he has taken 2 seconds to travel another 4 meters. Here also, he has taken another 2 seconds to travel 4 meters. Here also, he has taken another 2 seconds to travel another 4 meters. He has traveled equal distance in equal interval of time. Equal time. Then the motion is said to be uniform motion. If a person or if a body travels equal distance in equal time, then the motion is said to be uniform motion. Now, if you calculate the speed at each point, what is the formula for speed? So, speed equal to distance by time. So, between A and B, the distance is 4 meters. What is the time? 2. That is 4 by 2. 2 ones to 2s. 2 meters per second. Next, B to C, the distance is 4 and the time is 2. Therefore, speed equal to 4 by 2. 2 ones to 2s, that is 2 meters per second. In this way, if you calculate the speed at any interval, it is A to B or B to C or C to D or D to E, we are going to get 2 meters per second. So, hence that speed is known as uniform speed. So, when a body traveling in uniform motion, its speed is known as uniform speed. If a body travels in particular direction, then it is said to be uniform velocity. Uniform velocity. So, a body which moves with uniform speed in particular direction, then it is said to be uniform velocity. This is about uniform motion, uniform speed, uniform velocity. In the same way, there will be non-uniform motion. If a body travels unequal distance in equal interval of time, then the body is said to be having non-uniform motion. So, non-uniform motion. If a body travels unequal distance in equal time interval, then the body is said to be having non-uniform motion. So, for example, we have taken length, that is 16 meters. For first 2 seconds, it travelled 4 meters. Next, for next 2 seconds, it travel 10 meters from the origin. For next 2 seconds, it travel 14 meters from the origin. For next 2 seconds, it travels to end. So 16 meters from the origin. Here, for first 2 seconds, it has traveled 4 meters. For next 2 seconds, from the origin, it has traveled 6 meters. For next 2 seconds, it has traveled from, difference. So from the origin, it has traveled here 10 meters means between these two, it is 6 meters. Between these two, it is 4 meters. If you observe here, the difference is 6 meters. Here, if you observe, the difference is 4 meters. Here, if you observe, the difference is 2 meters. In this way, it is traveling unequal distance in equal interval of time. So, such motion is said to be non-uniform motion. An example for non-uniform motion is a housefly flying. So, or a butterfly moving in a beautiful garden. These are the example for non-uniform motion. When you come to the uniform motion, can you give the example for uniform motion? No doubt. The motion of hands in a watch is an example for uniform motion. The rotation and the revolution of the earth, it is also an example for uniform motion. So you can message some of the example for uniform motion or non-uniform motion to our college ID. Okay. Next, coming to the next parameter in kinematics, that is acceleration. Acceleration. When the body possesses acceleration, means when there is change in velocity. So, if there is change in velocity, then the body possesses acceleration. If there is change in velocity, if the body have velocity changes, then it undergoes acceleration. For example, what is change in velocity? Change in velocity means simple. Final velocity minus initial velocity. Final velocity minus initial velocity. That gives change in velocity. What is final velocity and what is initial velocity? Means initial velocity means starting velocity. Initial velocity means starting velocity. Final velocity means ending velocity. So always final velocity is represented by the letter V and the initial velocity is represented by the letter U. This V minus U gives change in velocity. So the formula for acceleration equal to change in velocity by time. So in order to change the velocity, it takes some time. So change in velocity by time gives acceleration. So change in velocity, that is V minus U by time is t. So acceleration is represented by the letter A. A equal to V minus U by t. This is the formula for acceleration. Whenever the body undergoes change in velocity, it will have some acceleration. So acceleration V minus U by t. The units for acceleration is meter per second square. Remember this, meter per second square is the unit for acceleration. And in which direction the acceleration exists means in the direction of velocity. Whatever the direction of velocity, in that direction of velocity only the acceleration exists. So here also we are having two types of acceleration, that is positive acceleration and negative acceleration. Positive acceleration and negative acceleration. When the body is said to be having positive acceleration and when the final velocity final velocity is greater than initial velocity, then the body possesses positive velocity. When the final velocity is greater than initial velocity, the body is said to be having positive acceleration. For example, if you release a body, as the body moves down, the velocity increases, then the body is said to be having what type of acceleration? Positive acceleration. So negative acceleration means if final velocity of the body is less than initial velocity, then the body is said to be having negative acceleration. So if final velocity of the body is less than initial velocity, then the body is said to be having negative acceleration. So the example is, when you throw a body upwards, as the body moves up, its velocity slowly decreases due to gravitational force, and at maximum height it becomes 0. Then the body is said to be having negative acceleration. Here, change in velocity means, here there are three types. And for a body to occur acceleration, if the magnitude of the velocity changes, then there exists acceleration. Okay, for example, if a body moves with 20 meters per second to 40 meters per second, that means there is change in magnitude. When there is change in magnitude, no doubt acceleration exists. If there is change in direction also, then the acceleration exists. Why means, here the velocity is a vector quantity. So if the magnitude of the velocity changes or the direction of the velocity changes, then there exists change in acceleration. For example, a body moves 30 km per hour in eastwards and turns to south and also moves with the same velocity, that is 30 km per hour. Here there is no change in magnitude, but there is change in direction. So the acceleration exists. So in next class we are going to see non-uniform acceleration. Okay, until then, have a good day. Bye.